but not for a boot2root. So now we have this this 1337 port, which is very cliche, but we'll give it a shot, see what happens. I'm going to use netcat to just connect to it and see what happens. Netcat is like a much better thing to use. It's like a network Swiss Army knife. It's a thing to connect to ports with. A lot of people use it for popping shells, but it's also great for just connecting to unknown ports and kind of see what it does. And we don't get a banner from this at all. So my first reaction is, does it speak HTTP? So we're gonna get head HTTP 1. And so if you're typing, if you've seen this before and you try and replicate it, and then you always get errors, and then you're like, oh, we got an error, it's speaking HTTP. The reason you're getting errors is if you type get and then whatever, this could be slash, could be head, and then 1.1, a header that HTTP 1.1 requires is host. So you need to do host, or else it won't respond. It'll respond with that error that you're used to getting. So we'll just get, what this is saying is get the headers using HTTP protocol 1.1 at this host. And we still got the bad request. So I screwed that up regardless. But it is speaking HTTP, which is interesting. So let's use our web browser, and we'll go to this port, or this IP. Okay, so we're getting, a page with an image on it. If we look, there's, super simple HTML. At this point, this is where I'm going to want to start running burp as a web proxy to kind of man in the middle stuff. It lets me mess around with what gets sent to the server, mess around with what I get back. Do some spidering or fuzzing if I think I need to. But to facilitate all of that, I'm going to download an add-on called Foxy Proxy. Foxy Proxy is a proxy management add-on for Firefox and probably Chrome, but I do most of my web stuff from Firefox just because that's what I do. We're creatures of habit. So we're going to add this install, and then we'll restart. So it gives us this icon here. And what this does is it allows us to add proxies, various proxies. And while we're adding it, we can add them for very specific areas. So only certain traffic goes to certain proxies, and you can have multiple proxies if you want, or just one. It's super handy. So we're going to boot up burp, which the burp free version comes with Kali. You can download it for free from the PortSwigger website, but we'll just use this version. It's fine. Burp is great. It's relatively cheap for the stuff that it does. I think it's like $400 or somewhere around there for the full version. The free version is plenty to do most boot2roots or CTFs, stuff like that. The features that you get in the paid version are you get the where'd it go? You can get access to the scanner, which static scanners on web apps are of arguable usefulness. What it does let you do is the intruder plugin in the free version is throttled. But again, the free version will do everything that we want it to do. So we'll take a look at our proxy options, and it looks like burp is running on 8080. So we'll go into proxy details, and we'll do the good old 127001 on port 8080. And then we'll go over to the URL patterns, and we're just gonna word of the root, and we'll just say anything at 192.168.1.210. That's not very precise, obviously. If you're doing this on a real engagement, you want to be a little more precise, but this will work for us. And then you can set it up to where you can use proxy 8080 for all URLs, use default for all URLs, or you can do it based on the patterns, which is what we'll do. Shut up, Cortana. So just to test that it works, let's reload the site, and it's not working. Let's try that again. I don't think it's a socks proxy. So this is why you go through and do everything that you're gonna do before the live stream, just to make sure that it's working the way you expect it to. Let's just use this for everything. See if it works then. It's not going through the proxy. I don't think it's a socks proxy. What the Sam hell?
We are surrounded by millions of other species. Walking, flying, burrowing, stalking, chasing, fleeing, outpacing.
Animals strive to reach this one ultimate goal, to ensure the survival of the next generation. This one
So we're gonna use this.
to pass on their genes.
8080, right? I'm not being dumb. Yeah, 8080. Ah, stop it. Oh, so caches are cool, guys. If you're just going to the same site over and over and over again, your browser is going to be like, no, I just did that. So a shift click on the reload button will like force it to actually reload. So now we're seeing it here in our HTTP history. Burp does this cool thing where you can actually turn interception on, and so if I did this. If I did that, we'll see this here, and then we could modify this if we wanted. Like if this was a post, we could change some of the post variables, post parameters if we wanted, especially if they're doing some sort of client-side filtering. But really where I do most of my work is I will actually right-click. You can right-click just about any request anywhere and send it to anywhere else, and I like to operate in repeater. So what this allows you to do is you just click go, and there's your stuff. And then if I wanted to be like, okay, well, what's in images? Do I get a directory listing? Go. And it looks like we do. So we'll be flipping back and forth between the actual GUI and burp quite a bit, just because I like to be able to see the way things look. I guess you could go here to render as well. So we see three different images. Can't go this way. It's the one we've already seen. And then an extremely funny Legoless Lego picture. So what we can do, a couple different things. Where are we? So let's send this to Spider from here. So we're going to set items outside the scope. Would I like to modify the scope to include the item? Yes, I would love to modify the scope. So if you look here, we have the target, and this is where the we define scope. So if you're on an engagement, this is what you would make sure that, the stuff that you actually want to hit or that you're authorized to hit is in here before. Here's where the scope's listed. This is a sitemap of the scope. Before you start spidering or throwing, slinging exploits left and right, or anything like that. So here we are. Nothing super crazy. We can actually turn that off now because that's all we're going to find. But we'll go back to repeater and do a couple other things that I like to do right off the bat. Like, let's see if there's a robots.txt. This is usually used to usually restrict access to administrative areas from bots. Like you don't want Google crawling your admin.php. So in your robots.txt, you'd set up rules to kind of do that. But of course, that's the first place the bad guys are going to look to find out where your admin stuff is. So we actually, when we go to robots.txt, we get a image, which is very weird. If we pull this up, it's the same thing. I don't need to pull it up, but super weird. Robots.txt is obviously a text file. So let's take the look at the code here. And if we see, it's actually the 404 page. So, it's not giving us the robots.txt. But we do have this, which kind of looks like a base64 or some other kind of encoded string. I'm going to guess base64 because CTFs and boot2roots love base64, as does everyone, right? But we'll take this into decoder, and we'll decode as base64. And here we see what looks like to be another base64 string with closer on the end of it. So the way a lot of us recognize base64 is we see this equal sign on the back, and maybe you don't know why that's done. But so basically the way base64 works is that it requires a certain length, a certain number of bits in the string before it can encode it. So it actually pads the end with these equal signs. And you'll see up to 2 at the end of a base64 string. So let's go ahead and can we base60 do that again? Okay, so now we've got this here. So this looks like a path. So we'll just kind of put this in here. Now, for those of you who are wondering, because I just happened to, happen onto this, I think we spent pretty close to an hour kind of rooting around the site and seeing what we could find. And we actually encountered that 404 page like 4 times before we were like, hey, let's look at the source of the 404 page. And the other thing you might be thinking is, wow, guys, like there is no site that's ever going to have a base64 encoded path to some other place in the site on their 404 page. And that's true. But boot2roots and CTFs almost never actually mirror real life, right? The way real life works is that, people spend hours or days penetrating, testing an application or, an environment. And CTFs and boot2roots are meant to be taken in bite-sized chunks, right? You usually do them over a weekend or over a day. So they kind of take shortcuts. But what this does signify and what does happen in the real world is people have comments in code that they forget to take out. They have, administrative files or debug files that they forget to take out before they publish code or publish a website. So stuff like this does happen. It's not as transparent, but it's an example, right? So here we are. We're going to go here, and it looks like we've got some sort of login page. If we just kind of send this. So here's the login page. We can see the code here. We see there's a form with 2 inputs, name and password. and then they get submitted with the submit parameter. So if we actually log in, never. We don't ever want to see that again. We see this here. You'll see this post request in our proxy history. We get the index.php. Now we're posting to index.php with these variables. Username, password, and then submit. So, and then we see the response here saying the password's invalid. So let's send this to repeater just in case we need it later. The thing that is the obvious idea now is it's like, okay, we're at a login page on a PHP site. Let's just throw SQL injection at it. So there's a couple ways to do that. The obvious way that you'll see in a lot of boot2roots or war game CTFs is, it's just the standard like, end quote or 1 equals 1, semicolon dash dash, right? To kind of go over that, why that's this go-to move is what you're doing. What the code is on the back end is it's saying select row where such and such equals, and then open quotation mark, and it's expecting a username to be in here, and then end quotation, and then the rest of the statement or the rest of the web page code or something. So what we're actually doing is we end the quotation. We actually say where ID equals 1, and then we give it an actual Boolean statement or something for it to evaluate. And we say, or if 1 equals 1, do that too. And the database is like, well, 1 does equal 1, so let's go with that. The semicolon and the dash dash that you see, or sometimes you'll see this as a hash mark or a pound sign or whatever you want to call it. The semicolon ends a SQL statement, and then the dash dash or the pound sign are comment characters for different types of databases. And the reason that you need that, typically why you need that, is because at the end of the SQL statement in the web page code is going to be a final quote, and then you'll get a semicolon, and the web page processing your input is going to be like, wait a minute, we've got these extra quotation, these quotation marks and semicolons here. What's going on? Or it'll throw an error. So if you put a comment character there, it basically says ignore everything on the rest of this line. Another way to do this, because maybe the comment characters or semicolons are being filtered by SQL injection protection or whatever the web programmer's trying to do to prevent you from doing stuff like this, is something called quote balancing. So you can say 1, and then you can do something like 1 equals 1, and then you leave this open, right? So what that's doing is select all, or select whatever where ID equals 1, or if the string 1 equals the string 1, and then the rest of their statement closes this, right? This part here is actually the code in the website. So we just kind of leave that quotation mark open and let the website kind of close it out for us. So that's like not even SQL injection 101. That's like survey of SQL injection, and not very useful here because, as you can see, we're not even getting an error when we do this, right? So the DBA and web developer on the back end were pretty smart about this, and aren't going to let us in. So there is a tool if we're reasonably sure that SQL injection is required, which we are because we don't have any credentials for this. There is a tool called SQLMap. And what it does is it has a huge library of SQL injection techniques in its little, config files that it can try against different things. And we're going to use that to tell or divine, seek through the SQL injection gods and see if there's SQL injection in this form. So just kind of looking through this, we're going to need a -u to tell it what the URL is, which is going to be this guy. So we'll SQLMap -u, and we'll put that there. What else are we going to need? So we can, so we're going to tell it that it needs to be a post probably. So we'll have data equals. So let's, so data equals, and then we'll just give it this. And then what else do we need here? So cookies, we don't need any cookies. We're not logged in right now. So we can actually see if we have any cookies. We do have, we've got this guy. Oh, something interesting. Something we did try before, like before we tried SQLMap, because I typically don't like to try tools like this right off the bat. I try and kind of dig around and see if there's other things to do first. So one of the things we tried to do, and maybe you don't know that this exists in Burp, but if you take what appear to be random strings or, you know, encrypted blobs or whatever, there's a thing called sequencer that you can, where is it? Oh, I have to, so we'll send this to sequencer. So what this does is it actually replays a request over and over and over and over again, and it takes a huge sample of cookies or headers or, you know, any sort of token that there is, and runs a statistical analysis on it. So we'll analyze now, and so what it's showing us is that there is a really low, there's low variability, which means in this case, it means that it's not generating new sessions for us or new tokens for us. What this is actually used for on a real site or in a real engagement is if you're getting session tokens over and over again as you log into like a known account, like your own account, you can log in over and over and over again and see how the randomness applies across the token. And what you'll discover a lot of the time is that maybe either the beginning or the end of the token has really low variability, whereas the other side of it has a lot of randomness to it. And you'll discover that that really part of the token is actually just encoded characters. So maybe it's a it's encoded. It's like your username. And then there's like an encrypted blob at the end, or it's, your username : and then the password, and then an encrypted blob at the end. And then you can use that information to further exploit the website. So really cool tool, really cool functionality, not something that I can really demonstrate here, but it's worth looking into on your own. So, so we've got the data. Is there a way that we have to tell it to do post? No? Okay. We'll run this and see what comes back. Submit has boundaries. Do you want to inject side it? No, we're not going to inject inside posts or inside submit right now. Using an unescaped version of the test because of zero knowledge. So I don't actually know what type it is. So we'll just say sure. Reader not exploitable with null. Okay, so we just ran it, didn't really do much or try and interact with it much. We just hit yes and then no a bunch of times, and that's not a big deal. So it says here that nothing's injectable. Try to increase either the level or risk. What the level does is it attempts. Let's see if we can find that. I don't want to explain it incorrectly. So level and risk do two different things. One of them changes the type of methods that it'll try, whether it only tries to use like select. It might start using like update and delete and whatnot. The other one will start increasing the complexity of things, such as trying to use time-based SQL attacks, where it's actually detecting if something's injectable by inserting like sleep statements or wait statements into the query itself, and then timing how long it takes for a query to come back. So especially for something like this, where it's not giving us database errors, which is what we usually use to try and map out SQL injection, if we like do something like, username equals like Tim and then sleep 20, and then it waits 20 seconds to get back to us, we know that's injectable, even though we're not getting direct feedback from the database, because something in the background is processing those database commands. So let's check out SQLMap risk level. Let's see if we can find some documentation online. Oh yeah, it's all mad because we're going through burp. Cool. No. Okay, so obviously there's a lot more stuff here. So if we use level. Okay, so level is going to test for where things are injectable. So it'll test in cookie header values, user agent, refer. That's pretty cool. So for those of you who don't know or have just never thought about it, because it never occurred to me until someone told me, SQL injection can be anywhere, right? SQL injection doesn't necessarily have to be this like quickly reflected, like, oh, I put in, or 1 equals 1 and then logged in. It can be all kinds of stuff. And it can be stored SQL injection. I think people call that second order SQL injection or something like that. So if you put it in a cookie or refer or user agent, what happens a lot is those SQL injection strings will get put into logs. Those logs will be consumed and then stored into a database somewhere for further analytics. And then when somebody views those logs, views them through whatever application, there could be SQL injection in that application that's viewing them. Same with cross-site scripting and all kinds of shit. So cool stuff. The instructor for SANS 542, which is the web application pen testing class that SANS puts out, I took that recently, and the instructor says when he's on a web app engagement, he loads up all of his user agents and refer strings and everything with all kinds of cross-site scripting and SQL injection strings, just because you never know what's going to be vulnerable. So that's what level does. Let's see if we can find what risk does. Okay. So 2 will start doing heavy query time-based SQL injections, and then 3 adds OR-based SQL injections. Also might add update statement, which actually has the potential for corrupting data, right? If we're using update, you can actually change values inside of a database. the reason why that's in the risk is because you don't necessarily want to do that unless you have explicit permission from your client or the person who owns the database. So we have to be careful there. But let's do this. We will add level. And I believe level is, maybe I should have left that open. I think level's out of 5 and risk is out of 3. Yeah. And if I recall correctly, level, yeah, 1 through 5. So let's do risk because that's the one that had the extra types of SQL injections versus level, which had where it did the SQL injection. So let's see if we can. Appears that the provided value for post parameter submit has boundaries. We don't want to do submit probably. Redirect profile. Interesting. So we're going to take that. We're going to check out this profile. It just redirects to nothing. Let's, with the redirect, and this is something cool about Burp, is that we don't have to obey redirects, right? So here's this GET request. Here's the GET request for the profile.php, right? And then we get a response 302, but we still get stuff back, which is kind of weird. So let's send this to repeater. We'll go, and then we'll just not follow. I mean, this is what we want, right? So we're seeing something here. Okay, so this is kind of cool. So it looks like it's actually MySQL in the back end. So that can help us if later we need to do SQL injection. We'll know what type of comment character it uses. So that'll be useful. I want to skip test payload specific for other DBMs. Yeah, we don't, if it's MySQL, we don't want to test for like Postgres or, Oracle, Microsoft, MS SQL, stuff like that. We want to save time. Yeah, we can absolutely extend the level for MySQL based stuff. Injection not exploitable with null values. Sure. So while this is happening, we're going to keep exploring this profile. So if we So how did it, where did we see that again? It was like up here. Should we be union injectable with 2 columns? Maybe we should have done a -v or something so it show us like what actual query it was doing. Or I guess I could pass it through. Another thing you can do is that you can probably pass it through a proxy. It can also take burp proxy logs. Yeah. So we could actually shove this through burp if we wanted to see every request that it's putting through. Granted, we probably do not. Do you want to keep testing the others? Yes. Okay, so we're getting password is, so if we set password to this, we should be able to get some form of something. So it's taking a while because it's got to sleep 5 seconds, right? Or it's been longer than 5 seconds? Why is it? We haven't gotten a reply yet. So yeah, it's way longer than 5 seconds. So we can change this to so dbms equals MySQL, right? And then is there a specific field that we want to mess with? P test parameter. Let's just set, because we already did password, right? So let's just set P for username, because we know password set. We don't want to do submit. Submit's probably just like a true false kind of variable anyways, but we'll see. No, we can do that the next time, right? If we want. Try increasing. Well, that's weird. Username does not appear to be injectable. So what if... So we're sticking with... So if we stick with P password or parameter with the password parameter, it just says, "Yep, you can inject." So are we able to actually dump anything with that? That's something else that SQLMap can do. Is it'll let you actually dump database information, like by default. So. So do we want to dump the users? Oops. Yeah, so Control Shift is the keyboard shortcut to like copy and paste. So Control Shift C, Control Shift V in terminal. Control Shift C opens the web console, and so when I go back and forth a lot, I always mess that up. But yeah, let's just see if it'll show us the DBs. All right, this is taking a minute. Opening up another beer. Everybody's been pretty silent. Does anybody have like questions or comments as we're moving along here? All right. Yeah, so unfortunately, as we're doing this kind of time-based attack, it takes some time for it to do its magic. Every request that it wants to do is sleeping for 5 seconds. Yeah, time delay to 1 second. That's good. That's better. Hopefully. So now, admittedly, this is where I need to do some more research and reading is what exactly is going on here. So I know there are many there are many different types of like SQL injection attacks. There are things where you're trying to compare. So what it might be doing now, right now, since it's coming up one character at a time. I don't know if you can see this at the bottom of the screen, but it's kind of popping up one character at a time. So there's a type of database attack that if my 542 teacher hears me say the next words, he'll probably slap me. But I can't exactly remember how it works. But essentially what you're doing is you're using the like statement. DNS threads 5. Oh, that's a great idea. Is that going to be faster than this? Yeah, DBMS. Oh, I'm not doing the DBMS one. I went too far back. MySQL dump threads equal 5. Cool. Maybe that'll work faster. But so what it does is it actually goes through and it creates a query where it's like, is the database name like %m or under %m or over %m? And then the database is like, yes. And then it almost like plays hot potato, cold potato with the database, trying to suss out what each character thing is. Sure. So it's kind of a prolonged thing as it tries to like guess each character. And it's just one type of SQL exploitation. Okay. Going to switch it off automatically. Well, that's mean. So I guess with time-based attacks, it doesn't let you do the Route 9b. The next part, I've been to the next part. I have not finished it, but I know how it's done. I don't want to say what the next part is because, spoilers, but I do know what the next part is. I know how to solve it. I'm going to use this part to step away from the computer for about 5 minutes. I will return very briefly, hopefully.
If you really want to understand how the universe ticks, the LHC is what you need.
We're about to go back to the beginning of time. The time when the Higgs ruled the universe. It will change our understanding
to go for it.
That's what science at the Large Hadron Collider is all about.
We can stare at the face of creation, smash matter together at energies never before achieved.
We can stare at the face of creation, a beam of protons going that way,
At almost the speed of light, another beam of protons going that way. At almost the speed of light, they'll cross inside Atlas and recreate conditions that were present just after the beginning of the universe.
We can stare at the face of creation, smash matter together at energies never before achieved.
Hey everybody, I am back. Thank you for making the new people feel welcome. To confirm the answers to the questions, we're doing a boot2root. It's named Lord of the Root, and Root 9b just posted the link to it. We're about an hour in, so if you want to completely follow along, like if you don't want to jump into the middle and get all the spoilers and everything, I will be uploading this to YouTube later tonight after we finish, and it'll be up there forever. So feel free, if you don't, if you'd rather do that, you can do that.
To come to you, Carl Sagan, could you help me by putting into layman's terms what was involved with this Big Bang?
The early cosmos was everywhere white hot. But as time passed,
Calls for users.
expanded and cooled. Then little pockets of gas began to grow steadily brightening. We call them the galaxies.
It was the beginning of the universe and of time itself.
Time-based attacks are super great. So just to kind of reiterate, give everybody updates who weren't here earlier. This part is we got to this part about 3 to 3.5 hours in, and then it took a little time to figure out how to do the database dump and get it running, and then we basically called it after we finished this and got to the next challenge. So that whole thing took 4 hours in quote unquote real time. Let me grab. Yeah, the YouTube channel is under additional web presence on my channel. I'm also pulling it up because reasons, I guess. So, oh my god, I probably could have just told it what the table name were, or at least guessed. All right, so the first thing it does, let's just kind of go through this while we're waiting for it to run. The first thing it's doing is it's trying to figure out what database it's accessing, right? And then so it did is, if you recall, it did the character by character, figured out that the database name is called web app, and then so when it knows that, it can say, okay, well, show tables for web app, where database equals web app, and then it shows that, and it's like, okay, cool. Let me try and figure out the columns, and then that's where it starts doing the line by line by line, saying, is it similar to M? It's like, no, it's not M. Is it higher than M? Yes, it's higher than M. Okay, and then it kind of goes through. It's sort of like that. It works sort of like that guess, pick a number from 1 to 10 sort of thing, where it's they say. Pick a number 1 from 10, and then you're like, is it 5? And they're like, lower. Is it 3? And you try and pick the middle one. That's what it's doing, except it's using characters instead of integers. And then the database is like, it converts it to an integer or something for its evaluation. So there's some of you guys probably have seen this on Twitter before. Hacks for Pancakes. Leslie Carhart, I think her name is amazing forensics analyst. She wanted to put together just a movie of 5 minutes of hackers and infosec people doing their jobs, and it's just literally 5 minutes of somebody staring at a screen while shit like this happens. And then, post it up as a super Hollywood blockbuster. Oh my God. Let's do something else while this happens. So there was somebody who was it?
It's the biggest challenge we have yet faced.
The same thing that keeps the Earth warm. CO2 may make the Earth too warm. It holds in heat. Methane, chlorofluorocarbons, water vapor, and carbon dioxide. They all trap heat.
Man, everybody posts a lot or tweets a lot. I'm scrolling through the history for something that I swore was very recent, but it wasn't. Oh yeah, that's lame. So we can kind of do something else while I will take the ring. Is that going to be a password for something? Could be Frodo's password. If we're following along with the trivia of the movie or books as well. I want to show you guys what I was talking about earlier with war games and stuff, which are more kind of self-contained challenges. Do one thing at a time. Move this up. I guess I can do it here. We'll go to OverTheWire.org. So OverTheWire is a really cool site. has a bunch of different challenges, and one of the things that I love about OverTheWire is that there's a pretty slow ramp up to it. Bandit is essentially just a bunch of Linux challenges that are kind of hacker centric rather than, you know, dumping you right into like buffer overflow and you know, stack protection bypasses and stuff like that. It's like, hey, let's kind of get you started on Linux first, and it's a great introduction to some of the stuff that even seasoned Linux people might not know or might not have explored or might only know a little bit about. So while this is going, we can kind of do a little bit of this just to give you guys an idea of what it's like. So the way this works is that you SSH to here, and then you log in with whatever username and password you got from the previous one. So SSH to here, L bandit 0. And we'll use bandit 0. So, you know, it says that network access is limited. You know, it's got the stack protection has been, looks like, disabled for probably the later buffer overflow challenges and stuff. But the goal in these things, much like boot2roots and other similar things, is to you know, progress to the next level or privesc or whatever. So here we need to find the next password. So let's just kind of look at what we've got. And there's a readme, so we'll cat readme. And then that's the password for the next one. So it starts out super slow, right? But, you know, if people are not used to Linux or haven't had a lot of experience in Linux, then this is kind of the overview they need, right? We can, my boss, for example, freaking PhD in math, like way smarter than I will ever be about anything. But he's just not familiar with Linux. And so, you know, doing these challenges, he learned a lot about kind of just the different tool set and commands that you can use. Whereas somebody like me, I've been doing Linux administration for freaking ever. You know, I'm certainly not graybeard status, but I know my way around a bash shell. So these come kind of easy to me, but they don't always to everyone. So it's good practice. Even some of the later levels, I kind of stumbled on and I got to learn new things, which is fun. But it reminds me a lot of the Sans Net Wars, where like the first 2 levels is really just local Linux stuff. So for instance, if you're looking, you're like, okay, well, what the hell's going on here? And especially if you just do an ls, you're like, what is that? It looks like a hyphen. So you need to figure out how to open files with weird commands. So if you try and like cat that, well, that's command flag, right? It's waiting. It's like, where the hell is the option that you're trying to use? So the way you do things is you can use a backslash to escape stuff. Maybe not. There we go. So you use cat, which is just to print out a file or print out stuff. And then we tell it that inside the current working directory, dot, and then escape, basically don't interpret this as a command. We want to do the hyphen. So especially sometimes when you're dealing with, you know, special characters or, you know, tricky hidden files and stuff, you have to really get explicit about how you want to cat out a file or echo out a file. So we'll grab this, go into Bandit 2. Spaces and file names. So again, similar to the previous to the previous command, we have special characters, which are spaces. Now I keep hitting tab because that's what my muscle memory does, because it just automatically expands, you know, whatever file it can be. But if you don't know about tab, you would have to escape each space, right? So this file name. Or again, you can just tab, which is really just the shortcut of the ages. If you're using Bash and you haven't figured out tab yet, do it, because man, it saves a lot of keystrokes. So there's our password. So it looks like we got something down here, my precious root. So it looks like what it's printing out is passwords and then username. You know, well, ID, then password, then username. So maybe we'll get my precious root and then the username here in a second. We'll just do a couple more exercises while we wait for that. So for those of you who don't know what's going on, I know that the standard way to do things is user and then machine name. -L allows you to specify the user as a command argument or as a as an option, and I like it here because it's at the end. I don't have to like go to the beginning of the line and change everything. And it's a lot of back and forth. This is the way we used to do it, like way back in the day. So if we go into in here, there's a hidden file. So people call these hidden files. I call them dot files because they are not hidden in any way, shape, or form. They will not. All it takes is just -A in ls for all files. And give me all files. There's the dot files. It doesn't come up in the standard ls. You know, just like these other dot files, you know, the single dot, double dot. But they're not hidden, man. Like locate will find them, find will find them. Never treat them as hidden because they're not. So if we just cat hidden, and there we go. So it looks like